morning, students. So again, I will continue based on the definition of transpose of a matrix. Okay, you know the definition of transpose, that is by interchanging the rows and columns. Based on the transpose of a matrix to solve some more problems. Now look here, problem number 37. They asked in final exam, that is 2-mark question. I think that question was asked in the previous year. Now the question is, if A is the matrix of order 2 cross 2, that is cos alpha sin alpha minus sin alpha cos alpha. Now the question verify that transpose of A into A is equal to identity matrix R. Transpose of A into A is equal to identity matrix R. Now here take LHS part, that is A dash into A. A dash means for interchanging the rows and columns. In first two elements are cos alpha sin alpha, right in first column by interchanging the rows and columns. Whereas in second row minus sin alpha cos alpha, right in second column minus sin alpha cos alpha. This is A dash into A matrix. A matrix as it is cos alpha sin alpha minus sin alpha cos alpha. Okay? Now multiply those two matrices. That is equal to multiplication of these two matrices. How to multiply? Multiply row by column. Yes, cos alpha into cos alpha. That is cos square alpha. Minus sin alpha into minus sin alpha plus sin square alpha. Okay? Next, first row by second column. Cos alpha into sin alpha. Cos alpha sin alpha. Minus sin alpha into minus sin, that is cos alpha into sin alpha. Minus sin alpha into cos alpha. Minus sin alpha cos alpha. First row by second column. Take second row by first column. Sin alpha into cos alpha. Sin alpha cos alpha. Plus into minus. Minus cos alpha into sin alpha. Minus cos alpha into sin alpha. Take second row by second column. Sin alpha into sin alpha. Sin square alpha. Cos alpha into cos alpha. Plus cos square alpha is equal to sin square alpha plus cos square alpha using trigonometric identity 1 minus that is plus cos alpha sin alpha minus cos alpha sin alpha cancel, that is 0, plus sin alpha cos alpha minus sin alpha cos alpha cancel, that is 0, sin square alpha plus cos square alpha 1 0 0 1. This is nothing but what? Identity matrix R, that is equal to RHS. 2-1 question. Verify that A dash into A is equal to unit matrix R. Okay? Whereas 38 question. In reviewing 38, sub question number 1. Show that the matrix A is equal to 3 cross 3 matrix 1 minus 1 5 minus 1 2 1 5 1 3. Is a symmetric matrix. I think you know the definition of symmetric. A square matrix A is said to be symmetric if transpose of A is equal to A itself. Transpose of A is equal to A, that is known as symmetric matrix. Whereas transpose of A is equal to minus A, that is known as skew-symmetric matrix. Correct? So, show that this is symmetric by definition of symmetric to prove that A dash is equal to A. Now, to find A dash. Now, A dash is equal. A dash means what? By interchanging the rows and columns. In first two elements are 1 minus 1 5, right in first one. Second two elements are minus 1 2 1, right in second one. Third two elements are 5 1 3, right in third. This is A dash. Therefore, A dash is equal to, this is nothing but pure matrix. If A dash is equal to A satisfied, Hence A is what? Symmetric matrix. So remember, definition of symmetric matrix: a square matrix A is said to be symmetric if A dash is equal to A. Whereas second one, show that the matrix A is equal to 3 cross matrix 0 1 minus 1 minus 1 0 1 1 minus 1 0 is skew-symmetric. Definition of skew-symmetric: transpose of A is equal to minus A. Now again to find A dash. Definition of A dash: into changing the rows and columns. In first row elements are 0 1 minus 1, write in first column. Second row elements are minus 1 0 1, write in second column. Third row elements are 1 minus 1 0, write in third column. Okay. So A dash is equal to, now among those take minus sign common. Here minus sign common to you. Here I will take 0, minus sign common to 1, minus 1. Here minus 1, 0 plus 1. Take minus sign common 1. Here minus 1. Here 0. That is equal to minus. Comparing this with given data, you will tell anybody, are they same? Yes. This is nothing but what? A. So A dash is equal to minus A. Therefore, A dash is equal to minus A if this condition is satisfied. Hence, matrix A is skew-symmetric. Matrix A is skew-symmetric matrix. So remember the definition of symmetric and skew-symmetric. A square matrix A is said to be symmetric if transpose of A is equal to A, whereas a square matrix A is said to be skew-symmetric if transpose of A is equal to minus A. Okay. Next problem, problem number 39. For the matrix A is equal to 2 cross 2 matrix 1 5 6 7, verify that A plus A dash is a symmetric and A minus A dash is skew-symmetric. You know the definition of symmetric and skew-symmetric. Okay. Now first to find A plus A dash. First one. To find A plus A dash. What is A matrix? 2 cross 2 matrix. First row 1 5. Second row 6 7. Plus A dash. Transpose of matrix. Interchanging the rows and columns. First row elements are 1 5. Write in first column 6 7. Second column 6 7. That is, add the corresponding elements. 1 plus 1 2. 5 plus 6 11. 6 plus 5 11. 7 plus 7 4. This is A plus A dash. Okay. Now here let A plus A dash you call it as P. P and A plus A dash. Verify that A plus A dash is symmetric. A plus A dash is denoted by P. To prove that P is symmetric. Definition of symmetric: P dash is equal to P. Now, to find P dash and now P and now A plus A dash whole dash. You know A plus A dash. It's a transpose. Interchange the rows and columns. 2 11 first column, second column 11 4. So P dash is equal to, this is nothing but what? Given P. Therefore, what is P? P means A plus A dash. O dash is equal to P. P value A plus A dash. If B dash is equal to P, that condition is satisfied. Therefore, P is symmetric. P and therefore A plus A dash is a symmetric. Okay. A complete term here P and the column. Now prove that P is symmetric means to prove that P dash is equal to P. Similarly, second one, prove that A minus A dash is skew-symmetric. Let A minus A dash denoted by Q. It is Q1, correct? Where Q is equal to A minus A dash. What is A matrix? A matrix is first row 1 5, second row 6 7. Minus A dash, first column 1 5, second column 6 7. Okay. Now that is equal to, subtracting the corresponding elements. 1 minus 1 0, 5 minus 6 minus 1, 6 minus 5 1, 7 minus 7 3. This is Q. Q is nothing but that is A minus Q dash. Now, ಇದಕ್ಕೆ Q ಅಂತ ತಗೊಂಡಿದ್ದೀವಿ. To verify that Q is Skew-Symmetric. Definition of Skew-Symmetric. Q dash is equal to minus Q. Now, to find Q dash, Q value A minus A dash whole dash is equal to, you know, A minus A dash. It's a transpose. Interest intervals and columns. 0, minus 1, second column 1, 0. That is equal to. Among those, take minus sign common. Minus common ತೆಗೆದು ಅಥವಾ minus ನ ವರ್ಟಿಕಲ್ ಮಾಡ್ಕೊಳ್ಳಿ. 0, minus 1, minus into minus plus 1, minus 1. That is minus. This is nothing but what? Q. So, therefore, Q dash is equal to minus Q. That is Q means A minus A dash whole dash is equal to minus Q value A minus A dash. So, A minus A dash whole dash is equal to minus of A minus A dash. Then it is said to be Skew-Symmetric. Hence, A minus A dash is always Skew-Symmetric. Remember, and only addition kottaga it is symmetric matrix. A plus A dash is always symmetric matrix, whereas A minus A dash is always Skew-Symmetric matrix. Okay. Now from this result, observe it. A plus A dash is symmetric. Two ಮಾಡಿದ್ರಲ್ಲ, this is symmetric. A minus A dash is Skew-Symmetric. Okay. A plus A dash is symmetric. A minus A dash is Skew-Symmetric. Isn't it? So add those two. ಎರಡು add ಮಾಡಿ ಏನಾಗುತ್ತೆ? Adding those two. A plus A dash plus A minus A dash is equal to. This is called as P. This is called as P. Add those two. P plus Q. ಏನಾಗುತ್ತೆ? A cancel. That is A dash cancel. A plus A 2. Adding those two, A plus A dash plus A minus A dash is equal to 2. Now, divide by 2. ಎರಡು ಪಟ್ಟಿಯಿಂದ divide ಮಾಡಿ ಏನಾಗುತ್ತೆ? A plus A dash plus A minus A dash divided by 2 is equal to A. Or A is equal to, we can write 1 by 2 into bracket A plus A dash plus A minus A dash. We conclude that ನಮಗೆ ಎರಡು ರಿಸಲ್ಟ್ ಇಂದ ಏನು ನಮಗೆ ಕನ್ಕ್ಲೂಷನ್ ಸಿಕ್ತು? ಎರಡು ಸಿಮೆಟ್ರಿಕ್ ಮತ್ತು Skew-Symmetric ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅನ್ನು ಆಡ್ ಮಾಡಿದಾಗ 2 times the given matrix, 2 times the given matrix, 2 into given matrix, or the matrix A can be expressed as sum of symmetric and Skew-Symmetric matrix. That 1 by 2 is constant K times into that value. So remember, every square matrix, ನೋಡಿ ಕೊಟ್ಟಿರತಕ್ಕಂತ ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅನ್ನ, that square matrix can be expressed as sum of symmetric and Skew-Symmetric matrix. ನೆನಪಿಟ್ಕೊಳ್ಳಿ, ಸಿಮೆಟ್ರಿಕ್ ಮತ್ತು Skew-Symmetric ಮ್ಯಾಟ್ರಿಕ್ಸ್ ನ ಎಡಿಷನ್ ಗೆ ಯಾವ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಈಕ್ವಲ್ ಆಗಿರುತ್ತೆ? given matrix A. So remember, note that every square matrix, each square matrix can be expressed as sum of symmetric and Skew-Symmetric matrix. Remember, this is the formula. Now they will ask, one matrix ಕೊಟ್ಬಿಟ್ಟು ಇದೇ matrix ಕೊಟ್ಬಿಟ್ಟು verify that matrix can be expressed as sum of symmetric and Skew-Symmetric matrix. Okay, so remember, every square matrix can be expressed as sum of symmetric and Skew-Symmetric matrix. Now, ಕೊಟ್ಟಿರತಕ್ಕಂತ ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅದಕ್ಕೆ ಈಕ್ವಲ್ ಆಗುತ್ತೆ sum of symmetric and Skew-Symmetric. Also remember, A plus A dash is always symmetric, whereas A minus A dash is always Skew-Symmetric matrix. Okay, so based on this, to verify some problems. Okay, remember, note that any square matrix can be expressed as sum of a symmetric and Skew-Symmetric skew-symmetric matrix. ನೋಡಿ symmetric matrix ಮತ್ತು skew-symmetric matrix ನ addition ಗೆ given matrix satisfy ಆಗುತ್ತೆ. That is A B A square matrix. Then A can be expressed as sum of symmetric and skew-symmetric matrix. The formula A is equal to 1 by 2 into bracket A plus A dash plus A minus A dash. Remember. Okay. Based on this, they will ask you for an exam. Express the matrix B is equal to 3 cross 2 minus Q1. This matrix can be expressed as sum of symmetric and skew-symmetric matrix. ಈ ಕೊಟ್ಟಿರತಕ್ಕಂತ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಇದಕ್ಕೆ ಈಕ್ವಲ್ ಆಗಿರುತ್ತೆ sum of symmetric and skew-symmetric matrix. That is B can be expressed as 1 by 2 into B plus B dash plus B minus B dash. Okay. Now here given data B is the matrix. Given B is the matrix 2 minus 2 minus 4 minus 1 3 4 1 minus 2 minus 3. Then to find B dash. B dash is equal to B dash means transpose of matrix by interchanging the rows and columns. In first two elements are 2 minus 2 minus 4. Write in first column 2 minus 2 minus 4. Second row minus 1 3 4. Write in second column minus 1 3 4. Third row 1 minus 2 minus 3. Write in third column 1 minus 2 minus 3. This is B dash. Next you find B plus B dash. Let B plus B dash is equal. What is B matrix? 2 minus 2 minus 4 minus 1 3 4 1 minus 2 minus 3 plus B dash transpose of matrix 2 minus 1 1 minus 2 3 minus 2 minus 4 4 minus. Both the matrices having same order, adding the corresponding elements, that is equal to add those two 2 plus 2 4 minus 2 minus 1 minus 3 minus 4 plus 1 minus 3 minus 1 minus 2 minus 3 3 plus 3 6 4 plus of minus 2 2 1 plus of minus 4 minus 3 minus 2 plus 4 2 minus 3 minus 3 minus 6. Okay, we got B plus B dash. Now multiply 1 by 1. Let P is equal to 1 by 2 into bracket B plus B dash. Now that first part denoted by P, that is 1 by 2. What is B plus B dash? 4 minus 3 minus 3 minus 3 6 2 minus 3 2 minus 6. Right. Now by scalar multiplication, multiply each element by 1 by 2. प्रत्येक element 1 by 2 multiply क्या होते 1 by 2 into 4 2 1 by 2 into minus 3 by 2 1 by 2 into minus 3 by 2 again here minus 3 by 2 1 by 2 into 6 3 1 by 2 into 2 1 1 by 2 into minus 3 by 2 1 by 2 into 2 1 1 by 2 into minus 6 minus 3. Now this is symmetric. Clearly P is symmetric. Already verified. That is definition of symmetric is P dash is equal to. Next you find B minus B dash. Also B minus B dash is equal to B matrix 2 minus 2 minus 4 minus 1 3 4 1 minus 2 minus 3 minus B dash transpose of that matrix 2 minus 1 1 minus 2 3 minus 2 minus 4 4 minus 3. Both the matrices having same order, subtracting the corresponding elements. Subtract from the 2 minus 2 0 minus 2 minus 4 minus 1 plus 1 that is minus 1 minus 4 minus 1 minus 5. Second line minus 1 minus 4 minus 2 plus 2 that is 1 3 minus 3 0 4 minus 4 minus 2 plus 2 that is 6 1 minus of minus 4, 5, minus 2, minus 4, minus 6, minus 3, minus of minus 3 plus 3, that is 0. Okay. Now, let Q is equal to 1 by 2 into B minus B dash. To find 1 by 2 into B minus B dash, because B matrix is given. So that is given by Q, 1 by B minus B dash, that is 0 minus 1 minus 5. 1 0 6, 5 minus 6 0 is equal to, by scalar multiplication, multiply each element by 1 by 2. 1 by 2 into 0, 1, that is 0. 1 by 2 into minus 1, minus 1 by 2. 1 by 2 into minus 5, minus 5 by 2. 1 by 2 into 1, 1 by 2. 1 by 2 into 0, 0. 1 by 2 into 6, 3. 1 by 2 into 5, 5 by 2. 1 by 2 into minus 6, minus 3. 1 by 2 into 0, 0. This is Skew-Symmetric. Now already verified, clearly Q is Skew-Symmetric. Minus sign into it is Skew-Symmetric, plus sign into it symmetric. Now Skew-Symmetric, that is Q dash is equal to minus. We got 1 by 2 B plus B dash and 1 by 2 B minus B dash. That is find out. And these two, add is a matrix curve. That is the result. Okay. Now P plus Q is equal to, you know P as well as Q. P means half of B plus B dash. Q means 1 by 2 B minus B dash. Add those two. P matrix is only 2 minus 3 by 2 minus 3 by 2. Second row minus 3 by 2, 3, 1. Third row minus 3 by 2, 1 minus 3. This is P. Plus Q. Q 0 minus 1 by 2 minus 5 by 2. 1 by 2 0 3. 5 by 2 minus 3 0. Both the matrices having same order, adding the corresponding elements. 2 plus 0 2 minus 3 by 2 plus into minus 1 by 2 minus 3 by 2 plus into minus 5 by 2. Second line, minus 3 by 2 plus 1 by 2. 3 plus 0 3. 1 plus 3 4. Right? Then minus 3 by 2 plus 5 by 2. 1 minus 3 minus 2. Minus 3 minus 0 minus 2. Simplify. P plus Q is equal to matrix 2. First two of the first 2. Here simplify. LCM is 2. Minus 3 minus 1 minus 4. Minus 4 divided by 2 is minus 2. Right? Again LCM is 2. Minus 3 minus 5 minus 8 divided by 2 minus 4. Second line. LCM is 2. Minus 3 plus 1 minus 2 by 2, that is minus 1. Then 3. Then 4. Minus 3 by 2 plus 5 by 2, LCM 2, minus 3 plus 5 2, 2 by 2 1, then minus 2, here minus 1. This is P. Check it. P plus Q is equal to, this is nothing but given matrix. B matrix is already 2 minus 2 minus 4, minus 1 3 4, 1 minus 2, minus 3. Is it satisfied? Yes. Hence, every matrix can be expressed as sum of symmetric and skew-symmetric matrices. Portray the square matrix, so equal sum of symmetric and skew-symmetric. Symmetric matrix A plus A dash is always symmetric. Skew-symmetric A minus A dash is always skew-symmetric matrix. So remember that no, every square matrix can be expressed as sum of a symmetric and skew-symmetric. Let A be a square matrix, that square matrix B can be expressed as A is equal to 1 by 2 into bracket A plus A dash plus A minus A dash. Now the question, express that matrix can be expressed as sum of symmetric and skew-symmetric matrix. So this one is the 3-mark question. Clear? Next problem number 41. based on the note, express the matrix A is equal to 2 cross 2 matrix. First row 3 5, second row 1 minus 1. Second problem, first row 1 5, second row minus 1 2. Third one, A is the matrix 3 cross 2 matrix. 3 3 minus 1, minus 4 minus 2 1, minus 4 minus 5 2. And fourth one, A is the matrix 6 minus 2 2, minus 2 3 minus 1, 2 minus 1 3. These matrices as the sum of symmetric and skew-symmetric matrix. ಒಟ್ಟಂತ ಮ್ಯಾಟ್ರಿಕ್ಸ್ equal ಆಗಿರುತ್ತೆ sum of symmetric and skew-symmetric matrix. Now look here. Now first problem, that is 41st sub question number 1. Given data A is the matrix 2 cross 2 matrix 3 5 1 minus 1. Now to prove that matrix can be expressed as sum of symmetric and skew-symmetric matrix. Now to find A dash. Therefore, A dash is equal to definition of transpose, interchanging the rows and columns. First column 3 5, second column 1 minus 1. Right? Then add these two. A plus A dash is equal to, what is A matrix? 3 5 1 minus 1 plus A dash is 3 1 5 minus 1. Adding the corresponding elements, 3 plus 3 6, 5 plus 1 6, 1 plus 5 6, minus 1 minus 1 minus 1. Okay. Now let P is equal to 1 by 2 into A plus A dash. Now to find 1 by 2 into A plus A dash, denoted by P, that is 1 by 2. What is A plus A dash? 6 6 6 minus 2. By scalar multiplication, multiply each element by 1 by 2. 1 by 2 into 6 3. Here 3. This is 3 minus 1. You know that A plus A dash is always what? Symmetric. Write directly. Clearly P is symmetric. Definition of symmetric, P dash is equal to P. Also to find A minus A dash. A minus A dash is equal to A matrix 3 5 1 minus 1 minus A dash matrix interchanging rows and columns 3 5 1 minus. Subtracting the corresponding elements, 3 minus 3 0, 5 minus 1 that is 4, 1 minus 5 minus 4, minus 1 minus of minus 1 plus 1 that is 0. Let Q is equal to 1 by 2 into A minus A dash. Multiply 1 by 2, that term denoted by Q. That is 1 by 2. A minus A dash is 0, 4, minus 4, 0. By scalar multiplication, 1 by 2 into 0, 0, 1 by 2 into 4, 2, 1 by 2 into minus 4, minus 2, 1 by 2 into 0, 0. Now here A minus A dash, remember clearly Q is what? Skew-symmetric. Difference of two matrices ಇತ್ತು ಅಂದ್ರೆ skew-symmetric ಆಗುತ್ತೆ. Sum ಇತ್ತು ಅಂದ್ರೆ symmetric matrix, that is Q dash is equal to minus. Now add those. Now P plus Q is equal to, P means symmetric matrix, Q means skew-symmetric matrix. Add those two, symmetric and skew-symmetric. P is matrix 3 3 3 minus 1 plus Q matrix symmetric matrix 0 2 minus 2 0. Correct? Simplify. Adding the corresponding elements, 3 plus 0 3, 3 plus 2 5, 3 minus 2 1, minus 1 plus 0 minus 1. Right? Observe it. This is nothing but what? A matrix. A matrix 3 5 1 minus 1. Yes. Therefore, every matrix A can be expressed as 1 by 2 into symmetric plus skew-symmetric matrix. Every square matrix can be expressed as sum of symmetric and skew-symmetric matrix. Among those, they class 1, each result carries 3 marks. Here go to verify that. or express the matrix A expressed as sum of symmetric and skew-symmetric matrix. Clear, students? Similarly, problem number 2, again 2 cross 2 matrix. Then problem number 3 and 4, 3 cross 3 matrix. Now try yourself these 3 problems, students. Try multiply these 3 problems as homework. Try yourself. Lowry square matrix. Verify that express the given matrix can be expressed as sum of symmetric and skew-symmetric matrix. Try yourself. Second one, third one, fourth one. You know some solve material. Okay, students. So to solve some more problems in the next class. Okay, students. Thank you.